All right, the purpose of this video is to help Algebra 2 students with the Chapter 1 practice test. We're going to walk through every problem. So here's problem 1. It says solve and graph the solution on a number line. So we're trying to solve for this variable x. We have to get it all by itself. Right now, I see there's this 8 on the same side. So if we subtract the 8 off of each side, we're left with negative 3x equals 18. And x still isn't by itself. Right now there's a negative 3 times the variable x. So to untimes that negative 3, we would divide both sides by negative 3. And we end up with x equals negative 6, since 18 divided by negative 3 is negative 6. Now to graph this on a number line, since x only equals that value negative 6, we just use a dot. So here's negative 6 on the number line. I'm just going to put a dot. That's what x is. Let's look at the next one. On number 2, we have to solve for y. So y is right there. Y is currently not alone on its side of the equal sign. There's a 16x there, and there's also a coefficient 8 in front of the y. So the first thing we could take care of is that 16x. Since the 16x is added to this side, we can subtract 16x from both sides. And that leaves us with 8y equals negative 16x plus 96. So now, the 16x that was there, it now appears over here as a negative. We've moved it to the other side. So now we have to get the y by itself. It's not by itself because that 8's there. So how do we get that 8 out of there? We have to unmultiply it. To unmultiply, we divide. And we have to divide each entire side by 8. So the 8's cancel here. We get y equals negative 16x plus 96 divided by 8. And sometimes we have to simplify, sometimes we don't. But in this case, since everything on the right side of the equation is divisible by 8, like negative 16 divided by 8 is simply negative 2. And the x doesn't change. 96 divided by 8 is 12. So there we go. Now it's solved for y, because y is all by itself on that side of the equation. On number 3, it says evaluate this expression when c equals negative 3. So the first thing I'm going to do is just rewrite the expression with a negative 3 in parentheses in place of where the c was. So the c is now a negative 3. Now order of operations says I have to start inside these grouping symbols, these parentheses. 2 times negative 3 is negative 6. Okay, we're still not done with the parentheses. Negative 6 plus 3 is negative 3. Now the next thing we need to do, since we've finished the operations in the parentheses, is we have to work on the exponents. I'm following, well, not PEMDAS anymore. We've been calling it GEMDAS. So the next thing I need to do is the exponents. Negative 3 to the third power means this. Negative 3 times negative 3 times negative 3. That negative right there is simply that negative there. So the negative 3 to the third power is that. And let's not forget our plus 7. Negative 3 times negative 3 is 9. 9 times negative 3 would be negative 27. Now, this negative, the one that wasn't really a part of that, has to be applied here. It's essentially a negative 1. So negative 1 times negative 27 would be a positive 27. And then 27 plus that 7 would be 34. There we go. On number 4, it says solve. The first thing we're going to want to put into place is the distributive property. So this 6 needs to be multiplied by this binomial. So 6 times x is 6x. 6 times 1 is 6. And now we need to get all the variables to one side of the equation. So if we subtract 2x from both sides, this side becomes 6x minus 2x is 4x. And on this other side, there's no x's, so that's good. We have all the x's on the left side of the equation. Now, I'm going to turn off the annoying zoom thing that happens. There we go. Okay, now to get to this 6 over to there, since it's being added to this side, let's subtract 6 from both sides. Negative 10 minus 6 would be negative 16. Now, the last thing we have to take care is that 4. So if we divide both sides by 4, we get x equals negative 4. There we go. Let's look at number 5. Okay, we have to solve and graph the inequality. This is an absolute value sign. And so the first thing I might do, and I learned this from Mr. Hammell, is if I cover that absolute value there, the absolute value of my finger has to be less than or equal to 9. So the distance that my finger is from 9 on the number line has to be less than or equal to 9. If I draw a quick number line, and I put a 0 here, I'm looking at the distance from 0. Here's 9. Here's negative 9. All the numbers from 9 to negative 9 are less than 9 units away from 0. Like this number right here, whatever that is, it's within 9 units from 0. This number right here, whatever that is, within 9 units of 0. But like if I draw a number out here, this would be more than 9 units from 0, so that doesn't work. So whatever is inside these absolute value signs has to be within 9 units, because it needs to be less than or equal to 9 units from 0. Its distance needs to be within that range. So how we do that is we say 4j minus 7, which was essentially my finger, needs to be less than or equal to 9, and 4j minus 7 needs to be greater than or equal to negative 9. If we get a number like negative 10, which would be out here, it would be 10 units away. It would be too much. So we need numbers that are greater than negative 9, like these numbers here, and less than a positive 9, these numbers here. So basically everything that's inside that interval is what 4j minus 7 needs to be. So now we go about solving each of these. Actually, before we solve these, we can actually combine these into a single inequality. See how the 4j minus 7 is greater than a negative 9, but the 4j minus 7 is less than a positive 9? Let's put the 4j minus 7 in the middle. So it needs to be less than or equal to a positive 9, but greater than or equal to a negative 9. Now we can solve this whole thing at once as a compound inequality. Let's start by adding 7 to all 3 parts of our inequality. So negative 9 plus 7, that's negative 2. 9 plus 7 is 16. All right. Now we've solved for 4j. We need to solve for just j. So if I divide everything by 4, that should get that 4 out of there. Negative 2 divided by 4 is negative 1/2. Or you might want to write this as negative 0.5. The 4's have canceled, so this is just a j. And 16 divided by 4 is 4. So either of these answers would be acceptable. Now the original problem said we need to graph, so we need to graph the interval from negative 1/2 to positive 4. Here's negative 1/2. So 0 might be about here, and I'll put a 4 way over here. This might not be perfect scale, but it will work. And because it's less than or equal to, that's going to be a solid dot. Since it's less than or equal to, another solid dot. And these are all the numbers that j can be. It can be like the number 1 or 2 or negative 0.1. but it can't be numbers like 5. That's too much. Or -3. That's too little. All right, number 6. Here we have to solve, and let's start with covering it with the finger again. The absolute value of my finger, so the distance my finger is from 0 on the number line, is 1 unit. There's 2 places that can happen, at -1 and +1. But since we're not talking about my finger, since we're talking about all of that there, let's just say that stuff either needs to be -1 or 1. So we have to just solve these 2 equations to figure out what Q's possible values can be. All right. Because this has fractions, and because a lot of us don't appreciate fractions, we might want to get rid of them right in the beginning. The least common denominator here is 3. So if I multiply this entire thing, both sides of the equation by 3, so times 3 there, here's what happens. 3 times 1/3 is just 1. So we're left with 1Q, or Q. 3 times -2/3 would be -2. 3 times -1 is just -3. So there we go, that's much simpler. There's no fractions left. Add 2 to both sides. Q equals -1. All right, let's look at this one. Same thing, gonna multiply the entire thing by 3. And we'd get Q minus 2 equals a +3 this time. Add 2 to both sides. Q equals 5. There we go. Now it said solve and graph the solution. So since these are just 2 values that Q can be, we can use 2 dots on the number line. So let's make this 0 and this -1. And we'll put a 5 right here. So Q can be 5. Solid dot, or Q can be -1, solid dot. All right, number 7, a word problem. First step, don't freak out. Just give it a try. See if you can break it down. And this one's not too bad. Frank's running 8 miles an hour. He runs for 90 minutes. How far did he go? Well, my first thought is, what's 90 minutes made up of? 90 minutes to me is made up of 1 hour, which is 60 minutes, plus another 30 minutes, which is a half hour. Now let's involve this. Frank runs 8 miles per hour. That means in this hour right here, he ran 8 miles. Now, since this is half an hour, 30 minutes, half of 8 miles, since he's only running for half of that hour, would be 4 miles. So together, it seems Frank ran 12 miles. This solution has a few assumptions though. For one, we have to assume Frank's running 8 miles per hour the entire time. We have to assume this is his average speed for that entire 90 minutes, which for most runners, they run at slightly different speeds as they go, as they get more tired or as they get amped up near the finish line. But the question was, how far did he go? Frank went 12 miles. Oh, this is problem 7, by the way. Let's look at the next one. Problem 8, solve for y. Okay, anytime you're trying to solve for a variable, you need to make sure all the occurrences of that variable are on the same side. So I see right now, there's y and there's y. So both the y's are on the same side. Let's get rid of non-y stuff, in particular this 5x. Since the 5x is added to that side, we can subtract it off each side. So I'm going to subtract 5x from both sides. And here's what we're left with. Okay, we have a y here and a y here. The only way to isolate that y is to factor it out. Since each of these terms contain a multiple y, a factor y, we can factor out the y. So let me move the y out here. Y times what would be 8y? 8. Y times what would be 4xy? 4x. Now, you can confirm you factored correctly by redistributing the y, and it should return you to your original term up there. So here's where we're at now. Y times the quantity 8 plus 4x equals negative 5x. I want the y by itself, and since this piece is multiplying, to get it out of there, I need to divide both sides by 8 plus 4x. So these terms would cancel, and we'd be left with y equals negative 5x all over 4x plus 8. Now I did switch the 4x and the 8 when I wrote it down here, and that's simply because of style. It looks better. Let's look at number 9. Okay, number 9 is a compound inequality. We have to figure out this and this. So let's solve each of these. On this one, let's divide both sides by, or subtract 9 from each side, pardon me. Since 9's being added, we would subtract to move it to the other side. So we have 2x is greater than or equal to 9, or 3 minus 9 is negative 6. Okay, now we have 2x. To get that 2 out of there, since it's multiplying, we divide. So let's divide both sides by 2. We get x is greater than or equal to negative 3. Now, let's look at this next one, since that one's done.